So now we come to the juicy part, and a very fairly important part in later applications also, because again a lot of future things will be derived from this idea, and it's a very easy idea as of now. So we are talking about a transversal. There is a line L and there is a line M, and the transversal is N, and it is cutting across two lines, and it is given that lines L and M are parallel. What does parallel mean? We have seen intersecting lines, and it could also be that I can't see the intersection, but I can see that they are going to intersect somewhere, right, in the future. So these lines, parallel lines, never intersect. The distance between them remains the same. If you measure the distance here and the distance is d, if you go ahead and measure the distance here, again the distance would also be d. Another way of looking at it is that imagine that instead of a line there is a scale, and I can physically move the scale. If you move the scale up and take it to this line, you will see that the angle between these two lines, I am moving this line here, the angle is 0. That means a relative rotation between them, because remember, an angle was giving me information about the rotation, how much movement across the circle is happening. This means that if you take the line and put it on top of the other line, the angle between them is 0, and that will remain the same. So lines L and M are parallel to each other, and N is a transversal cutting across these two lines. The first idea that we need to learn is that the pair of corresponding angles is going to be equal to each other. So if this was angle 1, angle 2, angle 3, angle 4, and this is angle 5, 6, 7 and 8, for starters, I am saying that angle 1 is equal to angle 5. Now, how do I come to this conclusion? What you can do is you can try this out for yourself. Draw two parallel lines, or open a standard notebook where there are ruled lines that are parallel to each other, and draw a transversal across it, and then measure these angles, and you will find them that they are equal to each other. And measure these angles, and you will find that they are equal to each other. So that is one way of proving by physical experience. You can draw multiple parallel lines, draw multiple transversals, and do it a few times to assure yourself that this angle and this angle in any scenario is going to be equal to each other. Another way that you can look at it is, if I take this line L and I just move it up or down, right? That means I'm not changing the rotation of the line, I'm just changing the physical placement. The angle, whatever angle it was making with the fixed reference is the same, or whatever angle it was making with any other line will remain the same. That means even if I move this line up and down, the angle is going to remain the same. I hope the animation also helps you see that. Once I see that, I can see that this line M is nothing but a copy of line L pulled down, and pulling down or pushing up does not change the angle. So using this, or intuitively, or by measuring, I can see angle 1 is equal to angle 5. Similarly, angle 2 is equal to angle 6. In fact, this you could have derived in other ways also. Once you take that angle 1 is equal to angle 5, you know angle 1 plus angle 2 is going to be 180. You know this is equal to angle 1 only. Angle 1 plus angle 6 is also going to be 180. And using that equation also, you can say angle 2 is equal to angle 6. Now, that's why we wanted to learn the term corresponding angles, because the moment I go to parallel lines, all the corresponding angles become equal to each other. So angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 4 is equal to angle 8, and angle 3 is equal to angle 7. So we'll see a lot more connections between these angles, but this is my foundation ground zero, that all the corresponding angles are equal to each other. Because once I know that, the other things I can again very quickly derive. Staying with the same parallel line, write down your results somewhere so far. Angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 4 is equal to angle 8, and angle 3 is equal to angle 7. Just keep this result on the side. The next result that I can go for, and it's a fairly important result used a lot, is that alternate angles are equal to each other. Alternate interior angles, let's say, are equal to each other. So I want to say that angle 3 is equal to angle 5. I know the corresponding angles are equal to each other, but how do I prove that this angle 5 is equal to angle 3? And I can do it very, very easily. Angle 1 and angle 3 are vertically opposite angles, something that we looked at in the last session. That means angle 1 is equal to angle 3. And we just looked at angle 1 is also equal to angle 5. So instead of angle 1, I can say angle 5. And therefore, angle 5 is equal to angle 3. Once I know this, pretty much the same process is going to repeat here. Angle 4 is equal to angle 6. Do prove it for yourself. Angle 4 is equal to angle 2. Angle 2 is equal to angle 6 because they are corresponding angles, and therefore angle 4 is equal to angle 6. So the alternate interior angle, and remember this shape because this shape will come in handy in a lot of problem solving, the Z shape. So these two angles are equal to each other, or you can create this Z shape and these two angles are equal to each other. So we know the corresponding pair of angles are equal to each other, and we also know the alternate interior angles are equal to each other. Let's look at alternate exterior angles now. And again, write down these results somewhere so that not only you know them and where they came from, they should be very, very familiar to you, so that next time you apply it in another problem when we say corresponding angles, you should know immediately what we're talking about. So this is not only easy but also fairly very important. So we have looked at corresponding angles, we looked at alternate interior angles. Let's draw this diagram again. Again, two parallel lines and the same transversal, and again the names are so again two parallel lines L and M, and there is a transversal cutting across. So we have looked at corresponding, we have looked at alternate interior. What about alternate exterior? What about angle 2 and angle 8? What can I say about them? And by now I should be able to make that jump very quickly. Angle 2 is going to be equal to angle 6 because of the corresponding pair, right? And I know that angle 6 is going to be equal to angle 8 because they are vertically opposite angles. So I can say angle 2 is also equal to angle 8. Similarly, angle 1 is equal to angle 7. Why? Because angle 1 is equal to angle 3. Angle 3 was equal to angle 7. Therefore angle 1 is equal to angle 7. So not only the alternate interior angles, the alternate exterior angles are also equal to each other. What else can we notice in the story? Again two lines, again the same. What else can we learn from this story? So we have looked at corresponding angles are equal, we have looked at alternate interior angles are equal, we looked at alternate exterior angles are also equal to each other. While discussing the terms, we also looked at interior angles on the same side of the transversal, angle 3 and angle 6. And I want to show that angle 3 plus angle 6 is going to be 180 degree. How can I do that? And by now the process should be fairly intuitive. You know angle 2 plus angle 3 is going to be 180 degree because this is a straight line and this is the big angle. You know this angle on a straight line is 180 degree. This angle is made up of angle 2 plus 3. So angle 2 plus angle 3 is equal to 180 degree. And you know instead of 2 you can write angle 6. So instead of 2 you can write angle 6. Angle 6 plus angle 3 is equal to 180 degree. And that's it. You proved it. So interior angles on the same side, the total of their angles is always going to be 180 degree. Can the same result be proven for angle 4 plus angle 5? Yes, it can be using very much the same process. Angle 1 plus angle 4 is going to be 180 degree. Instead of angle 1, I'll write angle 5 and I'll get angle 5 plus angle 4 is also going to be 180 degree. So that's it. That covers all our results when a transversal is cutting across a parallel line. The corresponding angles are equal to each other, and instead of memorizing the term, try and understand the term, that what do I mean by correspondence. So notice that angle 1 and angle 5 are very much alike. They correspond with each other. So all the corresponding angles were equal. We know the alternate interior angles are going to be equal. So angle 4 is equal to angle 6, angle 3 is equal to angle 5. We also know alternate exterior is going to be equal, and now finally we also know the sum of interior angles on the same side of the transversal is also going to be 180 degree. So go through this result a couple of times and you can try out very easy questions Maybe a very basic question that you can do is draw a transversal across two parallels, and they say this angle is given. Using a single angle, can I find the rest of the angles? Try that for yourself and make a couple of different stories. Change the value, change the position of the angle, and see what happens till you are very, very familiar and comfortable with these terms. Because first of all, we'll obviously look at a couple of problems just with this idea, but you will notice it over and over again as we move to triangles and quadrilaterals. Wherever we go, this idea of parallel lines and corresponding angles and alternate interior angles will come in handy over and over again. So be very comfortable with this.